Good afternoon, everybody. Welcome to another exciting and St. Patrick's Day Chem 170 with your host, me, Dr. White. All right, important announcements. Number one, after I finish my lecture today, which should go till about, let's see, about 3:15, and after we do the lab, I will, within about 10 minutes to the end of that, send out an email with the password for test number 2, which you can download from the assignment area of D2L. You'll have until tomorrow, and since I'm teaching tomorrow, I figure I'll give you till 1 o'clock, 1 p.m. to upload it as a single PDF file. You've already done that for test 1. Do the same thing, and I'll get it. Now, a couple things. First of all, before you upload it, look at your PDF file. Make sure you've done all the you've taken pictures or scanned all the pages, or if you're handwriting it, all the pages with your answers on it. You don't want to lose points because you forgot to scan it. Next, check your PDF file that you can read it. Make sure there's enough light if you use a smartphone. Anybody ever find a dumb phone yet? But anyways, when you have taken, or if you have a scanner, just check to make sure. If you can't read it, I sure can't. Anyways, today after class, I will, every hour or two, I'll be checking my email. If you have a question, ask. Also, tonight I have my office hours. And if you have a question during the test, ask. Now, if you haven't noticed, next week is spring break for you people. And I guess, yay, be safe, wear a mask. Unless you're going to Texas and then still wear a mask. Same thing in Florida. But anyways, what that means is no class next week. However, by Sunday, I will post in D2L the scores for test number 2 by Sunday. Did I say Wednesday? By Sunday, I'll do that, probably earlier. Same thing, I'll also, like test 1, send out an email with all the important information, your points for each answer you put. And then when we come back, not next Monday, but the Monday after that, I will go through all the answers with test number 2, but I will remove that from the video. If you can't make it then, make sure, come to my office hours. And I will have office hours tonight if you have any question. Also, this year, doesn't always happen, but this year it did, 2 schools I teach at, ECC has your spring break next week, and COD has it the week after. So next week, if you need extra help, and if you want, or you don't have to, I'll still have my office hours. No class, but I'll still have my office hours in case you need extra help. All right, one other important thing I want to talk about. A couple of you have not been handing in labs or missing labs. I'm going to give an amnesty until the Wednesday or Friday, and I'll put out an email when we come back after spring break for you to hand in all the missing labs. Now, if you can't get to the link to download it, email me and I'll send it to you. If you can't get to that link to upload it, just email me the lab. If you're having problems, remember next week I still will have office hours to help you out. And with that, make sure you do all the labs because they're important points. If you're missing 5 labs, you've just lost 55 points, which can't help your grade. All right.
Am I one of those people?
I don't know. Go look.
Because I should be up to date, but I haven't seen my scores updated.
All right. I have done, I think, I'll check later today. This week I've been swamped with stuff. Probably tomorrow or Friday, I'll make this promise. By Sunday afternoon, check D2L. If there's not a score in there for a lab that has been done and you should have uploaded it, contact me. And I'll work with you, whoever, not only you, Tom, but anybody else, to make sure you have the opportunity to catch up and do it. Okay? Because I want you all to do well. And if you're not handing your labs in, It's not going to help your grade at all. All right. Now, the material I'm going to go over now, remember, that's test number 3 material. So let's get to carboxylic acids. And just to remind you, a carboxylic acid is a carbonyl, carbon double bond oxygen with a hydroxyl group and an R group on the carbonyl carbon. And we talked about, everybody see my whiteboard? Thumbs up, people, thank you. And we talked about how do you name this? Name the longest chain with the carbonyl carbon as an alkane, drop the E at the end of the alkane name and add OIC and the word acid. And we went through also common names like vinegar and things like that. Oh, I have to. Did anybody drive by a gas station and see this gasoline contains up to 10% ethanol? That's an alcohol. Anybody look at a bottle of isopropyl alcohol, or rubbing alcohol, I should say? It's got isopropyl alcohol. It's an alcohol. Did you look at the bottle of nail polish remover you might have in your house? See, I removed all my nail polish before I taught, and I don't use it. But anyways, then that might have acetone, and that's a ketone. Remember, organic chemistry is all around you. I stole that from SpongeBob, and it won't hurt to think about it. All right, let's get back to carboxyl gases. Now, carboxylic acids are acids because this hydrogen on the oxygen is acidic. If I react it with a base, where M here for this class is lithium, potassium, or sodium, you'll get a carboxylate anion plus water, but I only asked for the organic, and there you go. And we did some of those, so let's try one real quick. And test 3, like test 2, I'll have a couple synthesis problems. So here's one. What would you react with sodium hydroxide to make that molecule? Your turn. And the votes are coming in. I think everybody's done. I think I'm going to do thumbs up next time. And let's do this. And remember, it still is true. Look at a molecule, look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. If we look right here, oh, that's different. And we'll be talking more about it today. This is a carboxylate anion. And what do you react with a base of this form where M is sodium, which in our case it is, potassium, or lithium? And the answer is a carboxylic acid. What's R? This. Therefore, 3 carbons to my carbonyl, because notice I have 1, 2, 3, 4 total. I better start with 4. And there are 4 bonds to carbon. So I know how to put in the hydrogens, and that's how you do it. And that's how you react carboxylic acids with a base, acid-base. Now, there's one special acid-base reaction, wrong thing, right thing. And that is the reaction of a carboxylic acid with sodium bicarbonate, which is baking powder. And what you get is the carboxylate anion, water, and carbon dioxide. And see the little arrow here? It's given off as a gas. So when you react a carboxylic acid with baking powder, you get the carboxylate anion, water, and gas, CO2 bubbles. And the next time you burp, most of what's coming out in your burp is carbon dioxide. Also, if you look at the little bubbles in pop, remember I'm from Chicagoland, and stuff in bottles that are cans that's carbonated without alcohol, we call pop, not soda. Or if you look at a bottle or a can of beer or sparkling wine or champagne, the bubbles are also CO2. Now, watch closely. Getting ahead of myself. And let's look at the following. Give all the products, and this is different. Normally, I just ask for organic. Here, I'm asking for all the products for the following reaction. And if we look here, what's different? Oh, hydroxy group, carbonyl, carbons, carboxylic acid. Then sodium bicarbonate, baking powder. And what you get the carboxylate anion of the carboxylic acid plus water plus carbon dioxide given off as a gas. Well, what's my R here? This. Therefore, I'll have those, my carbonyl, my anion here. Remember, you don't have to put charges, but Dr. White will. And then you get water plus carbon dioxide given off. And the question is, why do you get all this from this reaction? What I'm going to show you is called the mechanism. And you do not have to write this down, but Dr. White thought I'd share it with you. If you look at baking powder, it's really the structure. And here's our baking powder. Here's our carboxylic acid. This proton transfers over to give this carboxylate anion plus this intermediate. Now, the reason I'm drawing it in brackets here is you can't isolate it. This is called carbonic acid. And carbonic acid immediately, once it's formed, breaks down to carbon dioxide and water. This H and this OH make the water, this oxygen, carbon, oxygen make the CO2. And that's why it happens. So it's time for you to have some fun. And why don't you give all the products for the following reaction? 4 points. I want to, I could make it 6. For those of you turning on your webcam, thank you. As I mentioned on Monday, that article that sort of focused in my mind how what a positive motivation is for your instructor to see students out there alive and working on stuff in my class. So thank you. All right, I know some of you like to do the thumbs up better than the poll. If you're done, give me a thumbs up. All right, I think everybody's done. Let's do it. Now, if we look here, look at the molecules involved. What's different? That's another way of saying what functional group are we dealing with? Hydroxyl group on a carbonyl, carbons, carboxylic acid. Ooh, sodium bicarbonate, baking powder. And I'll write it underneath just because I feel like doing it. And what do you get? You get the carboxylate anion of the carboxylic acid you start, plus water, plus carbon dioxide given off as a gas, which is what that arrow shows us. So what's our here? Methyl. Therefore, I'll get methyl, I'll get my carboxylate anion, this. The cation is sodium, you don't want to show, and I get water plus CO2. Can anybody see the significance of this reaction you just did?
I would think because of the H2O and CO2, it's got to be a biological process.
Nope. Good try, though.
Okay.
Organic chemistry, even though a lot of biology is organic, I better tell you about this. It's time for Dr. White to talk about the first ever chemical reaction I ever did, period, when with my hands, when you were born or before your body's doing chemical reactions, but the first one I ever did with my hands. Now, I was quite blessed, and I was, that I had a father who was a pharmacist but really wanted to be a chemist. I love chemistry. I wonder why I became a chemist. Well, when I was about 5 years old, the big thing going on in our life was the space race with the evil Soviets, the communists, now the Russians. But then it was a space race with the communists. So everything you could think of toys-wise, everything had to do with rocket ships in space. Now, one of the things they sold was about this big. It was a plastic tube, and I'll draw a picture of it, by the way. Warning, Dr. White never had any inklings of ever going to art school. My mother was a very good amateur artist, and not one bit of it rubbed off on me. So when I do any artwork the rest of the semester, be careful, don't break any ribs laughing too hard, but it's allowed to laugh, and don't fall off your chair either. But anyways, there are these little rocket ship, about this big, had a hollow tube and a cap that looked like the fins of a rocket ship. Inside were these little beads of candy. That was the most god-awful candy in the world. How could you tell it was that bad? Because it only cost about a penny. Back then, it was serious money, but not that bad. And you could tell it was so bad because you give it to a 5-year-old who knew about it. They'd open the cap, take the candy, dump it in a garbage can, and then put the cap back on. Now you had a little rocket to play with. It was that, oh, it was bad. Well, anyways, my father showed me something neat. And let me show you what he showed me. All right. You can tell I'm not going to be an artist ever. I was just bad. But anyways, here's the rocket ship, and they had candy in there. If you took this tube off where the candy was, yes, don't break a rib laughing. On a whiteboard, I'm not that much better. You turn it upside down, you got a tiny little test tube. And what he showed me is you put in some vinegar, which is essentially water and what? Acetic acid. And then two, you put in some baking powder, which is sodium bicarbonate. I see someone has a question. So, or is it an LOL? They're similar. Baking soda and baking powder are similar. Both have sodium bicarbonate, but baking powder has some extra stuff, which I'm not going to go into, but it makes a difference when you're cooking. So the answer is there's a big difference, but both contain sodium bicarbonate. Thank you, Justine. That's a good observation. Thank you very much. But anyways, you put in baking powder, and then when you do that, you slam the cap back on here, turn it over again. All right, you have all the stuff, and as I just showed you, you'll get the carboxylate anion. You'll get water, but the most important thing you get little bubbles of CO2. So the pressure builds up in here. Ooh, I forgot the fins. Now it looks right. And the top would pop off. Let me see who's got a question or an observation. And it's a science fair volcano too. But when you're a 5-year-old kid and the thing was about this big and the cap was about that big, you hold it, you take test tube, put it in there, slam the cap on, shake it and hold it. It would go if your timing was good. And after you tried it enough times, my timing and my friend's timings were quite good. It would fly about 6-7 feet. And to a little 5-6-year-old, wow, is that the coolest thing in the world? All my friends thought my father was the coolest thing in the world too, and he was. But anyways, we used to do that. Now, there was a bad part of the story I have to tell. My best friend at the time, Dickie Gale, and I haven't seen him in a couple of decades. We lost contact. He went and moved out of state, and we just lost contact. But anyways, we're about 5 or 6 at the time. And Dickie Gale used up all his mother's baking powder and didn't tell her. So she went to cook and where's my baking powder? Oh, did he catch it? I don't even want to say what happened to him. It was bad. So remember, if you do this, don't use up all your mother's baking powder without telling her. And it's a lot of fun. Be careful if you want in your kitchen, take some baking powder in the sink with vinegar and watch the bubbles. It's fun. But then again, I'm an organic chemist. All right. Now, what we are making are carboxylate anions or carboxylate salts. And I just thought I'd tell you a few places where you find them, because now we're getting into part of a semester where you can ask, why am I learning about this? Well, if you take benzoic acid with a base, you can make sodium benzoate. And later today, I'll teach you how you get that name. And that's the structure. And this is found as a preservative in pop. Now, if you take propanoic acid and react it with calcium hydroxide or calcium carbonate, you make calcium propanoate. And that's again, carboxylate anion. And that's used as a preservative in commercial bread and bakery goods. I don't know about you, but how would you like to go to a bakery, or if you get Wonder Bread? I'm not big on that. I like better bread quality, but that's my personal thing. But anyways, my sister loves Wonder Bread peanut butter and jelly sandwiches on Wonder Bread. I'm not a peanut butter and jelly person. I don't even like peanut butter. But anyways, if you go and you buy your loaf of bread, how would you like to come home the next day or next day after you brought it home and see it's turning green? There's mold all over. No. Well, they put calcium propanoate to stop that. How it does it, I have no idea. I'm an organic chemist, not a biologist or whatever branch of science would know why that's stopping it, but I do know that happens. Now, another carboxylate anion is the reaction of calcium base with citric acid. And if you look on your screen, I don't know if you all see the structure. Do you see it on your screen? Thank you. This is calcium is a +2 ion, with cation, which I've stayed away from. Citrate has 3 carboxylate anions, so this is the actual structure. But if you go to any supermarket or big box store, or I get mine at Costco, you can get calcium citrate. And this is the best way to get calcium. You're not taking calcium metal in your body, you're taking calcium ions to help promote strong bones and healthy teeth. And that also is a carboxylate anion. And I'll teach you later on a special carboxylate anion, which has this structure where R plus the carbonyl carbon is long. What do I mean by long? Say 12 to 20 carbons. That's long. Usually about 16, 18 is the average. We call that soap. And I'll get into that later in the semester. I'll even teach you how soap works. So that's a coming attraction. Now, how do you make a carboxylic acid? One is oxidized and primary alcohol. Now, one thing I should point out for test number 2, I taught you this, and do this for test number 2. For test number 3, we'll do that, and I'll explain why in a second, or more than a second. Today, I'll get into that. So, if you have a primary alcohol, and you oxidize it. Remember, O in brackets means oxidize. And I won't go into specific oxidizing agents, even though we have talked about potassium permanganate, sodium dichromate, which we did in alcohols. And what happens is this gets lost and you form a carboxylic acid. And I've done these reactions because I worked a lot with carboxylic acids in grad school. And therefore, if I oxidize this molecule, what's different? Oh, it's an alcohol, plus it's a primary alcohol. If you oxidize it strongly enough, and here you probably heat it sometimes, you'll go to the carboxylic acid. And therefore, what's my R group here? Another way is to break carbon-carbon single bonds. I start out with 4, I better end up with 4. There's my R group. The carbon with the alcohol becomes the carbon double bond to carbon with the hydroxyl group. And that's how you do it. I've got carbonyl in the brain. Sorry about that. And why don't you try this one for your fun and enjoyment on this St. Patrick's Day, Wednesday. Remember, right after class today, I'll be sending out the password for test number 2. In fact, I even have a post-it on my mirror in my bathroom, reminding me my main bathroom upstairs here, test number 2, password. All right, I think everybody's done. So let's do this. If we look at this, I'm oxidizing something. What is this? Hydroxyl group on a carbon. And plus, this is a primary alcohol. If I oxidize it, I will get a carboxylic acid. What's my R group? What's ever attached to the carbon with the hydroxyl group, which will become my carbonyl carbon of the carboxylic acid. So if you look at it, 1, 2, 3, 4 across plus 2 methyls, 1, 2, 3, 4 across plus 2 methyls, and this becomes a carboxylic acid. And that's what you get. Oh, let's do another one. These are fun. And here's one more for you to have fun with. What would be the organic product or products for the following? And when you're done, give me a thumbs up. All right, I think everybody's done. Let's do this. What do I have? Ooh, an alcohol on a carbon. It's a primary alcohol. And I'm oxidizing it. And what do I get? A carboxylic acid. In this case, what's my R group? Methyl. And that's what I get. And I get that carboxylic acid. Now, like I said, we're getting into more and more important, juicy, everyday stuff. Anybody see the significance, and it's very important significance of that reaction of this alcohol going to this carboxylic acid? I'm going to make you think today. Anybody see it? Going once, twice. Give me a thumbs up if you give up. All right, I'll tell you what it is. What's this molecule? Ethanol. Ethyl alcohol. What's this molecule? Acetic acid. That's the common name. Nobody ever calls it ethanoic acid. And remember, about 4% acetic acid and about 96% water mixed together, and we call that vinegar. Now, what's the importance of this reaction? Well, there are two. Another question for you. In the United States, can anybody think about who is the greatest user who buys the most ethanol for their products in the whole United States? I'll give you 5 seconds. Oh, my hand still works.
Exxon.
Nope, you're wrong. Guess who it is? Heinz. Why? Because they convert the ethanol into acetic acid, which is used to make vinegar. Vinegar for their vinegar, vinegar for your mustard, vinegar for Heinz ketchup, and vinegar for the water or the pickling solution or brine, they call it, for your pickles. And Heinz buys the most ethanol in there. Now, that's one thing. Think about it. Next time you look at a bottle of ketchup, part of it comes from booze, ethanol. And the other thing is, if you think about that, what is a good oxidizing agent? I just inhaled the air you breathe. Oxygen can oxidize things very slowly, but it will. How many of you have ever opened a bottle of wine and it tastes like vinegar? And oh, that bottle went bad. In fact, after I graduated, one of my fraternity brothers, back then it was brand new area, he took computer science and was and still is a damn good programmer. And he was making tons of money because there was a whole new area and not that many people working with it. Well, he had a hobby. He loved wines. He'd go out and spend $100 on a bottle of wine. Well, at that time, he lived in a condo and he had a wall with all his wine bottles on there. Every once in a while, he ran out of room and he invited us over, a bunch of us who knew him. We're going to do a wine testing so I can get more room, open up more room to buy more wine because he loved buying wine. Well, once in a while, here's like $100 bottle of wine. We taste it and he said, oh, this went bad because some air got in there when they were corking it, or more air, and it turned the ethanol to acetic acid. And wine, when it goes bad, tastes like vinegar. And that's why. And he wasn't happy when that happened. Neither were we, because we were expecting a nice bottle of wine. But it was fun. So now you know the good and the bad of chemistry. Now, another way to make a carboxylic acid is by oxidizing an aldehyde, and you get a carboxylic acid. And that's a good way. And I did those reactions in grad school because I worked with aldehydes and carboxylic acids on my research. Now, one thing I want to show you for test 2, you've learned this. And now you're learning this. So that's why you can go all the way like this if you use strong enough conditions with your oxidizing agent. But let's talk about this reaction. If you take an aldehyde and oxidize it, you'll get a carboxylic acid. And if we look at this, what's the product of products? What do we have that's, ooh, an aldehyde. Carbonyl with a hydrogen and an R group. We're oxidizing it. And what do we get? A carboxylic acid. The carbon of the carbonyl carbon, all you do is replace this with OH. So here's my R group. Here's my carbonyl carbon, my 2 carbons, my carbonyl carbon, and the only change, I'll replace the H with here on the aldehyde with the OH to form a carboxylic acid. And that's how you do it. If I look at my clock, whoa, time flies. We're having fun. Come back in 5 minutes and we'll continue on. So please come back at 1:55 and we'll continue on with carboxylic acids. About ready to begin. Come on back. And don't forget, next week is spring break, so I'll have no classes, but because I'm still teaching at the other school next week, because they have spring break the following week, I'll still have my office hours. So if you want to stop by, say hello, or have any questions, stop by next week, but we will not have class or lab. And if you're going out of town on spring break, don't forget to send me an email. Having a good time. Glad you're not here. When I used to go to Europe a lot, each town, a city I was in, like if I went on a trip where I was in Amsterdam, Den Haag, Brussels, and then I'd go over to, say, Manchester, I'd buy postcards from that city. I had a list of about 30 people. I'd send all the people in my research group. That was over a dozen. And then some other people in the research building where I worked. And then friends and family, I'd send postcards. And I'd alternate on the postcards, having a good time, wish you were here, having a good time, glad you're not here. And I'd send them. And because I was staying at some very fancy hotels, very fancy, I just give them all 40 cards, say, put postage on, could you please, and mail it, and put the postage on my bill. And they did that always. And all my friends and neighbors and loved ones got my cards. It was fun. All right, let's get back to carboxylic gases. And here I showed you, if take an aldehyde, reacted with oxygen, you get a carboxylic acid. So it's your turn. And why don't you try this one? What would be the product or products, sort of organic products for the following reaction? And when you're done, give me a thumbs up if you'd like. I see this about, I see one person still working. Give you another 8.7 seconds. 0.6, 0.65, time's up. What do we have here that's different? Ooh, oxygen, double bond to carbon with the hydrogen carbons. That's an aldehyde. I'm oxidizing it. And what do I get? I get a carboxylic acid. What's my R group? All this. Remember, you don't break carbon-carbon single bonds. So I have 1, 2, 3, 4 cross plus my methyl. I still have 1, 2, 3, 4 cross plus my methyl. The carbon with the aldehyde carbonyl is still the carbonyl carbon. The H becomes a hydroxyl group. And I know there are 4 bonds to carbon. And there you go. And that's a really neat way of making carboxylic acids. Now, next way, I'm going to show you how to make carboxylic acids. It's cool. I mean, it's really cool. And that way is the reaction of a Grignard reagent. And I should have had here a Grignard plus carbon dioxide gives you a carboxylic acid that's 1 carbon longer than the R group you start with. A Grignard reaction with carbon dioxide, CO2, second step, acid and water gives you a carboxylic acid that's one carbon longer than the R group you started. Here's the R group, here's the new carbon. Now let's take a look at this first, because you wonder, how does this happen? And that's a good question. And good questions are always good to ask. That sounds like incorrect. But anyways, Grignard plus carbon dioxide, second step, acid and water, gives a carboxylic acid that's one carbon longer than the R group we started with. Remember, X here can be chlorine, bromine, or iodine. Well, how does this happen? Let's take a look, and what I'm going to do is turn the switch off, but I'm going to have some fun. Now, carbon dioxide looks like this. If you look at this part, wow, that looks like a carbonyl. And I know Grignards attack carbonyls, if I can get it right. Let's see if my aim is better now. And what happens is you now get this intermediate. And then when you, this is the carboxylate anions, which are bases. When you add acid and water in the second step, this is protonates an acid-base reaction, and you get your carboxylic acid, which is one carbon longer. You've made that something special, a carbon-carbon single bond. And why do I say this is a really cool reaction? Because one way to do it in the lab is, where do you get your CO2? Dry ice, which is otherwise known as solid CO2. I don't know if anybody ever calls it that, but in case you didn't know, now you do. And that's quite cold, minus 78 degrees Celsius, which is really cold. I know I ran a number of reactions using dry ice at minus 78. But anyways, let's get to work. And if you look at this reaction, what's the product or products, organic product or products? Here we have, ooh, a Grignard. This gives it away. Remember, X can be chlorine, bromine, or iodine, and plus CO2, second step, acid and water. This attacks that. You get a carboxylic acid that's one carbon longer than the R group you started with. So here I have my R group. I'll do that. And then my carbonyl, carbon. I know there are 4 bonds to carbon. And by the way, I'll never give this one as a synthesis on the test. I don't do that with Grignards. So that's how you do it. I better let you try one. And why don't you try this one for your fun and enjoyment on this St. Patrick's Day, Wednesday. And for those who know a little Irish, and this is about all I do know, Erin go bra, which means Ireland forever. At least that's what I was taught by my neighbor when I lived in East Lansing. She was Irish to the max. Kathleen, Kathy, I won't tell some of her, my memories are her getting wiped out on St. Patrick's Day. Those who are quicker than others, please be patient. I try and give everybody equal opportunity to finish. Finish. If you're done, give me a thumbs up. Well, this group is done. Thumbs up, people. All right, let's do it. What do we have here? It's different. Ooh, magnesium chloride on a carbon. This is a Grignard. Plus carbon dioxide, second step, acid and water. And we get a carboxylic acid that's one carbon longer. We made that special carbon-carbon single bond. And what's my R group? A cyclopentane ring. Which carbon has the Grignard? Is the carbon the CO2 is bonded to, not CO2, carboxylate anion. And that's the product you get. Oh, let's do one more. That's supposed to be a plus. That's better. Have fun. Your turn. I could be mean and say, go. Get going. Get to work. No, I won't. Get to work. It's the Wednesday before spring break. Dr. White needs a break. You probably need a break from me too. I shouldn't have said that. All right. Thumbs up, people. Are you done? All right, let's do it. What do we have here? What's different? Ooh, magnesium iodide on a carbon. That's a Grignard reagent, my hero, Victor Grignard. X can be chlorine, bromine, or in this case, it's iodine. And you react it with CO2, second step, acid and water. And what do you get? You get a carboxylic acid that's one carbon longer than the R group you started with. You made a special carbon-carbon single bond. What's R? Oh, my favorite, a T-butyl group. The carbon with the Grignard will be attached to a carbonyl hydroxyl group. I know there are 4 bonds to carbon, and I can put in my hydrogens, and I'm done. I've made carboxylic acids, and I've done this, and it's really fun reaction. What makes it fun? Very high yield, very easy to do, which is fun, at least in my book. All right, let's continue on. Well, that's everything I'm going to talk about carboxylic acids, but guess what time it is? It's new functional group time. And we're going to go over new functional groups, a couple of them. And in this chapter, what am I going to get into? Well, I'm going to get into something that smells really good. I mean, oh, is that good? Then I'm going to tell a personal story of how Dr. White had to get out of trouble with my mother. By the way, when I was a freshman and sophomore, and even junior in high school, I had a talent of getting my mother really, really, really upset with me. And I'll tell about that story. Not the part being upset, but how to get out of the doghouse when my father would say, did you get her mad at you again? Come on, use your brain once in a while. I don't know how it happened. Well, anyways, we'll get into that. And then I'll talk about something you'd never think I'd talk about. I mean, never think I'd talk about, but I will. All right, let's talk about carboxylic acid derivatives. Now, carboxylic acid derivatives, The word derivative comes from derived, which means made from. And these are new functional groups that we make from carboxylic acids. And these are compounds in which the hydroxyl group of a carboxylic acid is replaced with other groups, and we make new functional groups. Now, the one that I'm going to spend the most time on is an ester. And an ester is carbons to carbonyl carbon, then oxygen. Instead of a hydrogen, we have more carbons, which I'll call R prime. Let me write it bigger and clearer. And think of a carbon there, and this is an ester. And the other one, which I don't have time to talk about, are acid halides. When you replace the hydroxyl group of a carboxylic acid with a halogen here. And you know X can be chlorine, bromine, or iodine. And come to think of it, I've only worked with it as chlorine because they're the cheapest. And we talked about this type for Friedel-Crafts acylation, but I could spend a whole week or two reactions to that, but I'd rather spend it later on in the semester on proteins, carbohydrates, and fats and oils, because that's something I think a lot of you are interested in. So let's talk about esters. And esters are derived from, meaning made from, carboxylic acids. And that's where you replace the hydroxyl group of a carboxylic acid with OR prime. And this is an ester. Years ago, I had in a class of organic chemistry a student named Ester, the only time I ever did it. And funny quick story, every time in this class I'd say, all right, let's talk about esters. She'd look around, did you call on me? And I say, no, I didn't talk about you, Ester. I'm talking about this Ester. True story. She was glad when we were through with that chapter because she was getting whiplash. Did you call on me again? All right, so we have esters. Now, how do you name esters? I'm going to read through this, then I'll teach you it. As you know, I will. Name the R prime group bonded to the oxygen of the ester as an alkyl group. You know, like methyl, ethyl, T-butyl, whatever, that goes in front. Then change the name of the carboxylic acid used to make that ester. And I'll show you also another way. This is the official IUPAC. Drop the IC in the word acid, or actually this, and add ATE. And I'll show you another way that a student in Chem 1 70 years ago came up with, which works about 99% of the time. So that's how you do an ester. Well, let's do it. I haven't asked in a while. Thumbs up, people. Do you see the ester on your screen? Thank you. All right. Now, question is, give the IUPAC name for this. So first of all, what functional group? What's different carbonyl with an oxygen? And notice the carbonyl carbon has carbons, and now the oxygen has carbons. We call R prime. This is an ester. So the R prime you name as an alkyl group in front, ethyl. Now, how do you name this one? Now, if this were an H, that would be propanoic acid. And for esters, you drop the IC in the word acid. And then add ATE. the carbonyl carbon of an ester is always carbon number 1. So you don't put a 1 here because you can't have it on carbon 2. It's no longer an ester. And like I said, we added ATE. Now, except for when R is a benzene ring, the following will also work. Name R prime as a alkyl group, ethyl. Name, including the carbonyl, this is an alkane. And that would be propane. Drop the E and add OATE. I think this way for most of us is easier, and it's still ethyl propanoate. And that's how you do esters. Now, let me have you, let me do another one. And the first question is, what's different? Oh, carbonyl with an oxygen. It's got R on that oxygen and R prime and R to the carbonyl carbon. And we have an ester. And you name the R prime group as an alkyl group, CH3. Oh, it's your old friend, the methyl group. Oh, sorry about that. Then if you use my student's way, which you buy, there's 4 carbons, butane. Since it's an ester, we drop the E and add OATE. And if you use the IUPAC name rules, you'd get the same thing, methyl butanoate. Now, time for a St. Patrick's Day Dr. White gift. Now, when you have alkyl groups on this R part of the ester, you put them in here with numbers. Now, that's going to get awfully interesting quick. In other words, quite challenging. Here's my gift to you. On test number 3, and also on the final, I will never ask you to name an ester that has alkyl groups on the R. Dr. White knows how to do it, and I can teach you, but it can get pretty tricky and, ooh, what's going on here? And this way, I'm making your life a little easier. So thank you, Dr. White. You're welcome. And I hope you enjoy your St. Patrick's Day gift from me. And why don't you try this one? Give the IUPAC name for that, Ester. I see a thumbs up. I see a lot of thumbs up. So I better get to work. And how do you name this? What's different? Ooh, carbonyl with an oxygen. Carbons here, I'll call that R prime. Carbons here, I'll call that R. And that's an ester. How do you name it? You name R prime as the alkyl group it is in the front, methyl. Next, how many carbons do I have here? 1, 2, 3, 4, 5, 6, which would be hexane. Drop the E at OATE, methyl hexanoate. And that's how you do it. Now let's do the one where you can't use that student's method. And if we look here, oh, we got a benzene ring, but this takes priority in terms of the functional group naming. We have a carbonyl, oxygen, R prime, and my R group is the benzene ring. Now here you don't have a longest chain, so what do? R prime, you name as an alkyl group, and that would be ethyl. And then here, what would be, if this were an H instead of ethyl, that would be benzoic acid. Drop the IC in the word acid, and you add ATE, and that would be ethyl benzoate. Again, you have to use the IUPAC way. What would be the acid used to make that? Think of R prime as an H, name it, drop the IC in the word acid, and add ATE. So let me have you try one. And there you go. Have fun on this St. Patrick's Day. Hopefully you all got your corned beef and cabbage ready for dinner. All right, I think everybody's done. I better get to work. And how do we do this? We look at what's different. Carbonyl, oxygen, carbons here, carbons here. This is an ester. I name R prime in front. Oh, it's an isopropyl group as the alkyl, if I can spell. And then here, if this were an H, that would be benzoic acid. Drop the IC in the word acid and put ATE, and that would be isopropyl benzoate. Now, in nomenclature, there's two different. Well, actually, let me go over one other thing too. Then we'll go from the name to the structure. This is the carboxylate anion. And yes, IUPAC rules exist for this. And some people call it a salt. I like the anion better, even though truthfully it is a salt. How do you name that? You use similar rules for an ester. However, step one, I gotta go on spring break. Let me try it again. to name carboxylate anions, you name the M plus, just like you would R prime, but M plus, you name it as the element it comes from in the front. And the rest of this you name just like you would an ester. So let's look at one. And here, oh, this is a carboxylate anion. And how do you name that? You name what cation element sodium plus comes from. I just gave it away, the sodium. So you put sodium in front. And then how would you name that? Propane, which is, I just told you, the student's better way. Drop the E and add OATE. So the OATE ending can either be an ester or a carboxylate anion. If you see an element name in front, it's a carboxylate anion. If you see an alkyl group in front, it's an ester. Again, for these, I'll never put an alkyl group on the R, just like I won't for an ester. I know how to do it, but, and why don't you try this one? What would be the IUPAC name for the following molecule? 3 points each. I was just thinking, one time I was making a recipe, someone earlier brought up the difference between baking powder and baking soda. And I was making a potato kugel. Why did I think of that? Because Passover is coming up, and that's when you make a potato kugel one at a time. And I was having a bunch of people over to my apartment. I ran out of baking powder. I was making this the night before, put it in my refrigerator, and then pop it out and warm it up the next day. And when I ran out of baking powder, I used baking soda. Oh, it tasted awful. And I wound up throwing the whole thing out. And that night, going out and getting baking powder and redoing the whole thing. I was not a happy camper. And I learned the hard way the difference between baking powder and baking soda when you're cooking. Sometimes you use both, but they do make a difference. All right, let's do this. What do we have that's different? Carbonyl, oxygen, cation, R group. This is a carboxylate anion. And what's this? Potassium cation. So I'll put potassium in front. And then I'll use, since this is not a benzene ring, 1, 2, 3, 4, 5, pentane. Drop the E and add OATE. And just to show you one more, how would you do it? Carboxylate anion. And because R here is benzene ring, you can't use the trick the student gave me. And therefore, what am I going to do? I'm going to do the old-fashioned way. Sodium goes on front, not old-fashioned, the IUPAC. If this were an H, that would be benzoic acid. drop the IC in the word acid and add ATE, and this is sodium benzoate, which next time you drink some pop, my favorite is Dr. Pepper or Vernors. If you've never had Vernors, go to a local Jewel. I think some other places sell it, but I know they sell it in my Jewels around my house, and buy some. It's a very spicy, highly carbonated ginger ale, and I love it. And that's how you do it. Now, there's two skills when it comes to nomenclature. One is here's the structure, give the name. The other is here's the name, draw the structure. And how do you know what to draw? If you see ethyl octanoate, you start from the right, move left. OAT ending tells you either have an ester or a carboxylate anion. And how do you know the difference? Well, if you see an alkyl name in the front, it's an ester. If you see a alkali metal, which is what I'll use in this class, it's a carboxylate anion. Well, that's an alkyl group. If this were E, octane, 8 carbons. I have a carbonyl, oxygen. This is my R prime. And that's how you do it. And I'll give you one to try. And why don't you draw the structure for the following molecule? And when you're done, don't forget, please give a thumbs up. Looking to see if everybody's thumbs are up yet. I think so. Let's do it. How do you know what to name, draw? You start this way. OAT ending, ester or carboxylate anion. Alkyl group name in the front, ester. And the R prime is methyl. My R, including the carbonyl carbon, this were E, butane. Ester, what's my R prime? Methyl. And that's how you do it. Oh, let's do one more. These are fun. And why don't you do this one? Draw the structure for sodium propanoate. Oh, you guys are getting really fast. Thank you. I better get to work. How do you decode this? You start from the right, move left, OAT ending either ester or carboxylate anion. And if there's an element's name in the front, it's a carboxylate anion. And if we look at this part, if this were an E, that tells us what R plus the carbonyl, propane, 3 carbons. It's a carboxylate anion. The cation is sodium. And I'm done. Now, there's one common name for esters I would like you to know. And that's this ester. And this is a very heavily used compound in organic chemistry in our society. The IUPAC name, which nobody ever uses, is ethyl ethanoate. I have to think about that because I never use it. Everybody always uses the common name. And that would be ethyl acetate. Now, how do you get that? The R group ethyl. If we look at, if we score an H and use the common name, that'd be acetic acid, drop the IC in the word acid and add ATE and you get ethyl acetate. Where do you find ethyl acetate? It's one of the 2 molecules used for nail polish remover. Notice I took mine off. But anyways, for many, many years, ethyl acetate was the key molecule. If you go to a big box store, pick up a couple bottles from different areas of the long shelf, usually at my local Walmart and Target, both have it, a nail polish remover. And for many years, I'd go there every once in a while, look, it would be ethyl acetate. Why? Because unlike acetone, which I've also taught you as nail polish remover, it wouldn't sting if you had any cuticles that were sort of pulling away or cuts on near your nail, which is a good thing. Well, a couple of years ago, and I think most of you, I was taught about it for my Chem 170 students, they now have the nail polish you put under lights to cure, and that's super tough. By the way, nail polish is very high level, sophisticated organic chemistry, polymers it's called. Well, ethyl acetate didn't do a good job taking that off, so I was told by my students, and that's why acetone has made a comeback and taken more of the shelf space. But ethyl acetate is an ester that's good for removing your nail polish, and you should know that. Hint. Oh no, did you die on me again? All right, we're back in business. Now, one of the nice things is we're going on further into organic chemistry, we can find out more about chemicals we're using. And esters are found in nature. Mother Nature loves esters. Now, if you like certain fruits and vegetables, and if you like the smell of many flowers, what you smell and what you taste is an ester. And you should know that. Esters are responsible for the flavor of many fragrances in flowers and the taste of fruits and vegetables. Example would be pentyl acetate, which unfortunately we would make in the lab. We're not working in the lab, is the smell of bananas. When you taste a banana or smell it, you're smelling this ester. Now in roses, you're smelling a bunch of esters. These are common names, not IUPAC. And in a volatile ester, meaning it becomes a gas, you can smell it, of the scented rose, you have all these esters. Dr. White loves smelling roses. And perfumes are mainly mixture of esters. So next time you put in a perfume on, if you're using perfume, or men, aftershave lotion, You're putting on esters. Now, one other important, interesting thing is animals. I think most of you are aware when an animal goes into heat, that means the opposite sex, generally it's the male of that animal, that type of animal, like a dog or cat or other animals. Uh-oh, I better get the action. And they are in heat and the males go nuts. Well, why? Because they're smelling a certain chemical, and that's called a sex pheromone. And those are esters. Now, two quick ester stories. First of all, I said earlier, Dr. White, me, had a bad habit of getting my mother really, really upset with me in early high school. Later on, it wasn't that bad, but I don't know, we just didn't hit it off right for a couple of years. And whenever she got upset at me, my father would say to me, all right, now get her to be happy with you because I don't like living around her when she's mad at you. And there's one key way, surefire way I could get her to be happy with me again. That would be I'd go to Marshall Fields, now Macy's, in Old Orchard, and they knew me. I go to the perfume counter. My mother's favorite perfume was Chanel No. 5, which, if you know perfume, is not cheap. And the bigger the bottle, the more mad she was. And after a couple of years, 2 years, the women at the perfume counter at that Marshall Fields would come and say, what did you say to your mother now? How big a bottle do you need? How bad is it? And true story. Now, the other thing is, for many, many years, people, men and women, have been trying to find out, is there a sex pheromone for humans? In other words, what if you put something on, you attract males? And for over the years, there have been different scientists. Oh, I found it. And I think about 5, 6 years ago, some group of scientists said they found it. What attracts females to males? Sweat. I didn't buy into that. I don't think many women are going to say, oh, you come from the gym and you stink because you haven't taken a shower after your workout. I am attracted to you. Well, they claimed it. And obviously, you're not seeing men going out and buy bottles of sweat. Now, perfume is made to imitate a sex pheromone to attract a man to a woman or make her smell better. And that's that. Now, important play on this was about every 10 years you see a commercial. I haven't seen them for a couple of years, but I've seen 2 rounds of them. And they're selling cologne for men, otherwise known as perfume, but they give it a different name so it doesn't sound, oh, you're using something a woman uses, which is nothing wrong, but still. And the way that the advertisement goes is men, and you see this sort of nerdy guy put on this cologne, walk outside, and all of a sudden, all these beautiful women in bikinis attack him, and he's smiling. And it used to be canoe was one of them, and their punchline was, "Do you canoe?" And there are a couple others over the years. No, I don't think it works like that, but they'd like to. If you ever invent a sex pheromone or find one, you'll be quite wealthy. And with that, let's take a 5-minute break. I'll see you in 5 at 2:50, and I'll be right back in 5 minutes. Oh, give me a break. There'll be a slow, hang in there. My computer gets all upset, I think, with everything I'm running on it. All right, sorry about the delay. All right, everybody see aspirin on your screen? Switches off for this slide, but in case I'm giving you a headache, guess what? Aspirin is this molecule, which has both an ester and a carboxylic acid. There's a carbonyl carbon right there. And this is aspirin. Now, I know how to synthesize it, but how does aspirin relieve pain? I have no idea. I know how to make it as an organic chemist, but how it interacts in your body, I don't know. All right, now we're going to go through one more thing and then we'll do the lab and I'll let you go and send out the password. Thank you for letting me going a little later. But how do you make an ester? And that's called Fischer esterification. Emil Fischer, Dr. Fischer, is one of the great German organic chemists, and he's known, this alone would be a lifetime achievement, this reaction, but he's more well known for his work in carbohydrates and really simple sugars. And I'll talk more about that when we get into carbohydrates. So this is Fischer esterification, making an ester. And how do you make an ester? Simple. You take a carboxylic acid, react it now with an alcohol, and you use an acid catalyst. And what you get, you replace the hydroxyl group with OR prime, an ester. And if we take a look at one, and the question would be, what's the organic product or products of the following reaction? And we look at this molecule, what's different? Carbonyl hydroxyl group, carbons, that's a carboxylic acid. We look at this molecule, what's different? Carbon with a hydroxyl group, that's an alcohol. And acid catalysts usually use sulfuric acid as H+, and you'll form an ester. Do you break carbon-carbon single bonds? No. So I have my R group here, and here's R prime. Now it's important that the carbon with the hydroxyl group is the carbon with the oxygen, the ester. So I have my two carbons are carbonyl, oxygen, and then my isopropyl. And don't forget these hydrogens. And I'm done. I've made isopropyl acetate, which is a common name. Isopropyl ethanoate would be a UPAC name. And why don't you try this one for your fun and enjoyment on St. Patrick's Day? All right, looks like most of you are done, so I better get to work. And how do you do this? You look for what's different. Ooh, carbonyl hydroxy group carbons, carboxylic acid. Carbon, carbon, carbon. Ooh, hydroxyl group on a carbon, alcohol. Plus acid catalyst. And what do I get? An ester. What's our ethyl? What's our prime? This N-butyl. So I have my two carbons, my carbonyl. This is my R group, oxygen. My R prime, notice the N carbon has the hydroxyl group. So that carbon of 4 carbons will be bond. Oops, I'm seeing double. That carbon will be bonded to the oxygen. Now I know there are 4 bonds to carbon. And let's try another one. And here you go. And just think about it, next time you put on perfume or you buy perfume for someone else, think about it. You're just buying a lot of very complex esters. At least I don't know about now, but I'll bet you it's still true. In organic, industrial organic chemists, some of the highest paid organic chemists are working for perfume companies. When I got out of grad school, I applied to a couple because they make a lot of money. Unfortunately, I didn't work in those areas at that time, so I didn't get a job. They're on the East Coast, which was all right. I like staying in the Chicagoland anyways. All right, let's do this. I think everybody's done. What do I have here? Ooh, a benzene ring, but I also have, this will not react with a benzene ring, but I have a carbonyl hydroxyl group. So I'm going to call this a carboxylic acid, and it is. And carbon hydroxyl group, alcohol. And what do you get? You get an ester. What's my R group? The benzene ring. R prime, methyl. Don't forget the lines inside the benzene ring, otherwise that's cyclohexane. And this is the ester I get. Let's try a synthesis one. And what would be the two things you react along with acid catalyst to make that molecule? Now let's do the thumbs up when you're done. I see one person, I think it's done. Two people. And if you're done early, please be patient. I try and give everybody time to finish. Finish? No. All right, I think everybody's done. Let's take a look at this. How do you do the synthesis? By the way, synthesis is the fun part of organic chemistry. If I look here and say, what's different? Ooh, carbonyl, oxygen. Ooh, I've got carbons on the oxygen. I'll call R prime. Carbonyl carbon has R. This is an ester. How do I make an ester? A carboxylic acid plus an alcohol plus acid catalyst. If you don't put the acid catalyst in there, you could wait months and months before you make any ester. With the acid catalyst, it's done in about an hour or so, actually less depending on what you're making. So what's R? What's R prime? And therefore I'll come back here, R is CH3, carbonyl hydroxyl group. I have this carboxylic acid. R prime is ethyl, becomes this alcohol. And here are my answers. Now, time to make your brain hurt again. Anybody see the significance of this reaction? How many people give up? Give me a thumbs up. Oh, all right, I'll give in. All right, what's the significance? Well, if you're ever on a desert island and you need nail polish remover, ethyl acetate, and you don't have any, but you just happen to have some vinegar, acetic acid, and some alcohol, vodka, and some sulfuric acid, you can mix the two together, heat it up, and make your own ethyl acetate and remove your nail polish. Now you know I'm an organic chemist. All right, let's do the lab. And then afterward, I'll be able to then send out. Let me just close a few things here. Either I have a failing memory chip or I'll have to go out and clean it again. I did it just recently. Be with you in a second. All right. Let's put it up there. Everybody see the Aldehydes and Ketones Lab? Thank you. All right. Some of this you've seen before, but now we're going to do it in aldehyde and ketone. Remember, aldehyde is carbonyl with a hydrogen in our group. Ketone, carbonyl with two R groups, and they can be the same or different. And the first one, we're going to look at the solubility of ketones and aldehydes in water. And here we'll put, like we've done before with other labs, well, in some test tubes, we'll fill it about halfway with water, add a little of the compound we're testing, mix it, and then see if it's homogeneous or heterogeneous. If it's the same throughout, it's soluble. If it's not, it's insoluble. And in this table, you'll be using benzaldehyde, vanillin, cyclopentanone, heptaaldehyde. Oh, I used a common name. I'm sorry. That should be heptanal. I'll try and change it tomorrow probably. And 2-heptanone. Draw the structures underneath here. And here's the data. Now, the second part, I'd have you smell them, but I'm going to omit this. By the way, benzaldehyde, you already know, smells like cherries or almonds, vanilla, well, it's vanilla extract, and the others, well, I'll omit it. Now, when it comes to aldehydes and ketones, you can oxidize aldehydes, but not ketones. And let me show you. As we learned earlier today, for this chapter on carboxylic acids, aldehydes can be oxidized to a carboxylic acid. Now, the oxidizing agent, the stuff that's in the O bracket, will use potassium permanganate solution. That's purple. When it oxidizes an aldehyde, it becomes reduced and forms magnesium dioxide, magnesium oxide, manganese dioxide, excuse me. And that's a muddy brown color. And if you have a ketone and you react it with an oxidizing agent like potassium permanganate, there's no reaction. So if you have a compound and you're wondering, does it have an aldehyde? Or a ketone, and you know it has one of those in it, if it, when you oxidize it, react it with potassium permanganate, forms a muddy brown color, manganese dioxide, guess what? You've got an aldehyde. If it stays purple, because there's no reaction, you know you have a ketone. And that's what you'll do in this part of the section. If we were at ECC, you'd mix them together and observe. And what you'll do is put benzaldehyde in a test tube with some potassium permanganate solution, KMnO4, and then mix it. And if you did, you'd see a muddy brown. You'd put cyclopentanone and you'd see purple. And then to make it exciting, we have that unknown number one. And when you put potassium permanganate in, you get a muddy brown. And that's that part. And there are questions for that. Now, the last one. Oh, I'm so sorry we're not in the lab because this is so much fun. And this is called the crossed aldol condensation. Why cross? Because instead of using the same aldehyde, we're using a ketone plus an aldehyde crossed. Ta-da! And what you get is this compound, which common name is called dibenzyl acetone. And it's a yellow solid where these are clear liquids. And here's a YouTube video to show you what's happening. I think I had one here too you should look at. And let's look at something you can download. And this is where Dr. White has some fun. But before I do it, if we're in a lab, you take some benzaldehyde and acetone, mix it together. This is acetone. Nobody calls that 2-propanone. Add some ethanol. There should be under here. That's the solvent we're running it in instead of water. Works better. And then you stir it in an Erlenmeyer flask, and then you add some base, sodium hydroxide, and you swirl it, and you see these beautiful yellow crystals form. Afterward, you use what's called a Buchner funnel, which is a way of separating a solid from a liquid. You let the liquid dry, and this would be the melting point you get, which is approximately what the melting point is for dibenzyl acetone. And here's where Dr. White's going to have some fun. Now, this is called the mechanism. Everybody see the mechanism on your hand drawn? Thank you. If you start out with the benzaldehyde and the acetone reacted with base, something interesting. This aldehyde has no alpha hydrogens. On the benzene ring here, there's this carbon right here has no hydrogens, so you can't form the enolate anion. But the most important step of this whole reaction is base reacting with the alpha hydrogens, the hydrogens on the alpha carbon of acetone to form this enolate anion. And this attacks the carbonyl carbon to form this aldol product. Now, one of the things I haven't taught you is that whenever some atoms in a molecule can leave to form a stable molecule and also help form something more stable, they're out of there. We leave. And what's stable? Conjugated double bonds, alternating single, double, single, double, single, double. Well, if you look over here, I have a benzene ring with a double bond there, carbonyl double bond, and here I have a OH and a hydrogen. 2 hydrogens and an oxygen, 2 hydrogens and an oxygen. What could that be? Water. And if this loses water, between here you'll form a double bond, and now this is conjugated double, single, double, single, double, single, double, single, double. And it's happy, meaning more stable. Now, on the other side of this molecule now, we also have alpha hydrogens or hydrogens on the alpha carbon. Base forms this enolate anion. This also attacks that carbonyl carbon, opens it up to this aldol condensation product. And the same thing, Here I have a hydrogen hydrox group, oh, water. I'll form a double bond there and I'll improve the conjugation. Double, single, double would form there, single, double. And that happens. And this is the formula, or the structure actually, for dibenzyl aldehyde. Now, one of the things I sort of alluded to in aromatic ketones was the fact that because of conjugation of double bonds, it can absorb UV light. Now, this one does different. The compound is yellow. And what makes it yellow?